This is a Rockford Fosgate car audio amplifier. A Punch 360A2, I think is the model. Does not power up at all. No LED, no output, nothing. In fact, it hardly drew any current from the power supply. And originally I thought the little TL494 chip that controls the power supply was bad, but I found that one channel had shorted output transistors. I took those out thinking the amp would run with one good channel, but it still didn't power up. Although that time around I was getting about 3.5 volts on the power supply rails, and it should be a lot higher than that. So I looked around some more and discovered that the MOSFETs in the power supply output circuit were shorted. So I took all those out, and I'm going to have to replace all that stuff. I've got one shorted channel and a shorted power supply, and all of the output transistors and switching transistors are mounted on these special plates where the whole metal tab is soldered for cooling purposes. And a construction like this is very difficult for me to do on my bench because I just have normal soldering equipment. So what I'm going to do to heat this up, or what they call preheating, I'm going to heat this thing up with a hot plate to take a lot of the work off the soldering iron so that it doesn't take much to melt that solder and get it to flow under these metal tabs on these transistors. To buy a normal circuit board preheater is extremely expensive, so since I'm just doing this for fun and I've only got 15 or 20 bucks into parts on this, I figure I got nothing to lose. I'm just going to use a cheap electric skillet. It was like $18, and bring it up to a few hundred degrees, but of course not hot enough to harm it or melt the solder. And that'll make it much easier for my standard soldering equipment to flow the solder underneath these big transistors. Because normally you're going to sit there all day trying to heat that up, and it's just going to, the heat from your soldering iron is going to get absorbed into that aluminum heatsink, and it's just never going to melt, and you're going to end up pulling the foil off the board before you even get the transistor detached. I was able to remove those four using my desoldering iron because it's got, you know, I think it's about a 45 watt heating element on there, 45 or 65 watt, but it was still quite a bit of work. So I think using the hot plate will make it much easier. It's going to be the first time I've experimented with that technique of solder reworking. And if it doesn't work, so what? I'm just doing this to see if I can fix it. Okay, I've got this hot plate at about 250 degrees Fahrenheit. What I'm going to do is put some solder on this metal tab of this first transistor here, which will give me more surface area for the iron to contact it, and hopefully it'll heat it up fairly quick and I can just lift it off with my needle nose pliers. It's not sticking to the tab yet, which means it's not up to melting temperature yet, but it'll take a little bit here, and probably got to use quite a bit of solder just to get more area. Normally you would use a larger tip on the iron if you have one, but I don't, so I have to do it this way. Now get my pliers here. Alright. And she's up. Simple as that. The next step I do is I put 4 very small dots of fresh solder on there so that this transistor will sit level before the solder starts to melt, and it'll kind of help keep it in place. And then I'm going to use a rosin flux pen to put flux where the transistor will be sitting. And take my new transistor. This is a I think this is a Fairchild RFP 50N06. Get it centered on the in position as best I can, which is right about there. It's going to be difficult to keep it in place while I'm heating it up, but it's one reason why I like to preheat this. Makes it much easier. And just heating the tab of the transistor will melt that solder, and it should kind of fall into place under its own weight. And then I can add a little bit of solder around the edge, which should flow underneath if it needs to, and I'll be done. Still very difficult to keep this in position. I would normally use like some tape or something, but I think it's just going to be too hot for the tape. Plus the heat from the skillet is quite uncomfortable to be working in for very long. And here's both completed boards. You can see the excess solder on the transistor tabs that I was using to increase the area of my soldering iron tip. It's not the prettiest thing in the world, but it's not going to hurt a thing. Got, see, they go in the amp like this. So you've got your 4 power supply MOSFETs here that have been replaced, and 1 set of output MOSFETs. So all I got to do is bend the leads back into position where they were and install them on the board, and we'll give it a test. Now that I'm ready to reattach these to the main board, I need to sit everything in the case and make sure it's down snug, and then solder a couple leads from the top. And what that'll do is make sure that the height is proper, so that when this thing is all mounted in the case, it won't be putting pressure on the transistor leads when I tighten all the bolts down. I also had to clean all the old thermal grease out of here. It was a mess. It was all dried up and clumpy and was not fun to remove. Here's one channel almost ready. Like I said, I've put the boards into the case and put a couple screws in both to make sure they're in position, and then soldered a few of the leads from the top side so that it'll keep everything lined up, and I can solder the rest and put it back in, and everything will be nice and straight. You don't want these leads to be getting a lot of pressure put on them if they're not soldered in the right position when you go to tighten those screws down. Now I got to do the other side. Everything's back in place temporarily. I'm going to do a quick test, and if it powers up, then I'll take it back apart and put in the thermal grease and clean all the flux off the solder joints. I don't want to put it all back together and waste a bunch of thermal grease if it's not going to work. But I'm using a 10 amp regulated 12 volt power supply, which should be enough for test purposes. And when I connect this remote power lead, it's going to do one of two things. It's either going to turn on like it should, or it's going to produce copious amounts of smoke, which then I'll have to turn off the camera and produce a copious amount of cuss words. So let's see what happens. Well, I have power LED, and the power supply voltage did not budge, so that's a good indication that there's no shorts. I guess it'd be a good time to hook up some speakers and an input signal. I've got everything hooked up. I found that the screws for the speaker jacks, 2 of them are missing. They're 1032 size thread, so I used some big ugly rack mount screws. Good enough for test purposes, and if everything works, I'll get the proper screws at the hardware store later. I'm going to have to turn the volume down real low on the computer over there because I don't know how sensitive the gain is on this amplifier. But before I even put an input signal in, I'm going to put the power to it and make sure that nothing's wrong and no abnormal noises come out the speakers with no input signal. So turn this thing around here. I don't have a lot of room to work as far as all these cables. Things just won't get out of my way. So I think we're all set. Plug in the power supply. Okay, 13 volts. Well, no noise out of the speakers yet. Let me leave it on and go put a signal in and see what happens. I'm thinking it might not work, because usually these things will make at least a little bit of noise when you first turn them on. So anyway, let's see what happens here. Volume down. Oh wow, it works. Very sensitive gain. Talk about a sensitive input. It sounds really, really good so far though. Nice and clean. Sweet. Yeah, nice clean sounding amp so far. I guess I'm going to go ahead and put on the thermal grease and get everything finished up and put the cover back on. So far it's working great. Sounds good too. If you're wondering what song that was it was called Leto by Archie. I'm just trying to find some music I have that YouTube isn't going to flag or mute or give me a copyright strike. So I'm hoping that this one won't cause any of that to happen, because I put a lot of work into this video, and I'd hate for it to get pulled because of the doggone music I use to demonstrate it. It's one of the hardest things about having a channel with a lot of audio related stuff in it. It's hard to demonstrate stuff that you fix when they keep flagging your videos. But anyway, like I said, I'm going to take this back apart and put on the thermal grease and clean up the flux and stuff like that. Put it all back together. All back together, awaiting the final test. But here's a quick look at the label on the back. Manufactured, oh, it says handcrafted in the United States of America. Wow, you don't see that very often anymore. Do not chassis ground any speaker. 90 watts by 2 RMS into 4 ohms, 180 watts by 2 into 2 ohms. This thing's definitely been around. I'm going to try to clean this case up a little bit. All done. Now I just got to get the right screws for the speaker jacks. Also, I checked the power supply in the amp and it runs at plus and minus 35 volts. So it's about a 70 volt swing. That's pretty good. And I'm guessing these tabs here are for decorative covers that go over the sides. I'm not really sure. This thing sounds really good though. I wish I could turn it up louder, but it's about 2:30 in the morning now. It's too bad because I'd love to crank it. And if I get time later this weekend, I'm going to do a load test on this and see what it really puts out. It's nice to see this working again though. It was a fun project. Alright, that wraps it up. Hope you guys had fun with this video and maybe even learned something in the process.